All right, this is the Math 3H Unit 1 review. Our first task is to simplify what we have here. So following order of operations, we are going to do this multiply first. So we're going to do all that. So I'm just going to copy what I'm not using down to the next line. And then from here, we just got to combine like terms. So I have a 4x cubed here and a negative 6x cubed. So that's going to be negative 2x cubed. Then I have a 5x to the 6th and a positive 48x. So that will be 53x to the 6th. And then the other two don't have anything like it. So I'm going to write that, and then from here, I'm going to put them in descending order. So I have 12x to the 7th plus 53x to the 6th minus 2x cubed minus 3x squared. And sometimes students say, am I done? You're looking, can I combine like terms? And can I cancel any factors, do any order of operations? You can't, so that's as much as you can simplify. For the next one, same kind of idea. You're going to want to make sure that you proceed with caution. So I'm going to put that 5 down there, and then I'm actually going to distribute the minus 2. So minus 2x to the 4th plus 4x squared minus 10x cubed plus 8. And then I have to distribute this minus. Be very careful because you are subtracting here. You are not multiplying. So this is not a huge box method or anything like this. This is just going to change the sign of everything in the parentheses. And then from here, we're going to combine like terms. So I have a constant, 5. That's my only one. And then, oh, nope, it's not my only one. I have an 8. And then I have negative 2x to the 4th and negative 8x to the 4th. So the first one I have is 13. And then that's minus 10x to the 4th. Then I have a 4x squared and a 2x squared, both positive, so I get to add those. And then I have a negative 10x cubed and another negative 10x cubed. So minus 20x cubed. So putting these in standard form by powers of x. And I get that right there. Okay, so again, it's a little different than the next one where we do have some multiplying here, but this is just subtraction. So you just distribute it and then proceed as if you were adding or subtracting. Okay, next, this one, you can do 7x and 2, you can multiply, so you get 7x plus 14. But this over here is asking you to multiply, so you're going to want to make sure you multiply before you do that subtraction. So it's just going to be distributive property like this. So I get 2x squared minus x plus 8x minus 4. Again, order of operations says to take care of what's in the parentheses or brackets or grouping symbols first. So we get 2x squared plus 7x minus 4 inside, and then I can distribute that minus sign. Minus 2x squared minus 7x and plus 4. And then we're going to combine like terms now. So we have a 7x and a negative 7x, so those cancel. And then the next like term, 14 and 4 makes 18. And then we have the negative 2x squared by itself, so negative 2x squared plus 18. Okay, moving on to question 2. Oh, this one has a figure, and it says, write a polynomial that represents the volume of the box, but not including the shaded cube. So the first thing that you need to remember is that volume is length times width times height. So that was a funky H. We can do the outer one, and then we can do the inner one. So there's lots of different ways you can do this, but this says it's a cube. So the volume of the cube is just going to be x times x times x, which is just x cubed. So if we want the volume of the whole box, but not that cube, we're just going to end up subtracting out 8 cubed. For the rest of this right here, we need to figure out the dimensions. So one dimension is this one, so that's just going to be 2x plus 1. And then another dimension is that guy, which is just x minus 1. And then our third dimension is this one, which is 2x. So the volume of our rectangular prism, so the volume of the whole box, is going to be 2x times x minus 1 times 2x plus 1. Doesn't really matter the order of those. So that's the volume of the whole box. When we want to subtract out the cube, we'll do it once we've done the math for this. Okay. So for me, I always like to do my binomials first because it just seems easier. If you want to do the 2x into x minus 1 first and then go from there, you can. There's not any rule on that. So this would be 2x squared and then plus x minus 2x and minus 1. I'm going to clean up the parentheses before I do anything else. So I'm going to combine like terms with those x's. Now I'm going to distribute that in. So I get 4x cubed minus 2x squared minus 2x. So that's the volume of the entire box right there. But it said to take out the volume of the cube. And we already got the volume of the cube. So we are just going to take 4x cubed minus 2x squared minus 2x, and then we're going to subtract out that x cubed because that's the volume of the cube. And then that's just going to give us, when we combine like terms, 4x cubed minus 1x cubed is 3x cubed. And then minus 2x squared and minus 2x. All right, number 3 says write a function, g of x. So it tells us what to name that function. And then it says with the following parameters. So we're going to take the f graph and compress it by a factor of 1/2, then go left 4 units and down 6 units. So what this is just saying is go g of x equals, a compression is going to be in front, so it's going to multiply. And then we don't know the specific f function, so we're just going to label it f. And if we're going 4 units to the left, that's -4, and whatever's in the parentheses is opposite. So we put +4, and then the y don't lie. So that just is exactly what it says. It says it's down 6, so put -6. And for b, we got this reflection in the x-axis, which means that there is going to be a negative. And it's going to stretch the graph by a factor of 3, so that's going to go in front. And then we're going to translate it 8 units to the right. That's +8, but in the equation we do the opposite, so it's x minus 8. And since it is a horizontal movement, it has to be in the parentheses with the x. All right, let's take a look at the next one on transformations. Number 4 says, given this graph right here, describe the transformation of f of x to obtain g of x. Then we got to graph g of x, and then we also have to do all these other things for it. So whenever you're presented with this, the first thing that you're going to want to do, other than identify your transformations, is to pick some key points. So I'm going to do them in purple. So I'm going to pick this one, this one, this one, this one, this one, and I know it's a lot, and then this is going forever. So just keep in mind your graph is going to go forever that way. So I like to start with the least x value. So that's -1, -1. Then it goes up to 2, 1. Then it goes to, oops, I lied. This one is -3, -1. Then -2, 1. Then -1, -5. Then we're going to go 1, -3, 2, -4, and all the way up to 4, 2. So those are the starting points. This says to state the transformation. So right here we have reflect over x-axis. Make sure you put over x-axis. Okay, you will get marked down if you just put reflect, because in the math world there's lots of reflections. You need to be specific. Then we're going to do vert compression by 1/2. So make sure you put vert or vertical and compression, because there's horizontal and there's stretches. So we want to be clear by a factor of 1/2. And then we're going to go right 1 and up 4. So to get all those transformations on here, the first thing is it's going to multiply all the y values by -1/2, which is going to take care of that reflection over the x-axis, as well as the vertical compression by 1/2. And then I'm going to go right 1. So I'm going to add 1 to each of the x values, since x and right are both horizontal descriptions. And then I'm going to go up 4. And so I'm going to add 4 to all these y values. So then we just got to clean up that table so we can get a good graph. So let's see, -3 plus 1 is -2, -1, 0. The next one doesn't go to 1, it jumps to 2, then 3, then 5. And then when I go to do the math for the y's, a -1/2 times a -1 is 1/2, or 0.5. So this is just going to be 4.5. So -2, 4.5. Then I have 1 times -1/2, which is -0.5 plus 5, so that's 3.5. -1, and then it's still positive 3.5. 0, when we get to this one right here, -5 times -1/2 will be 2.5. And then plus 4, so that's 6.5. And then the next one, -3 times -1/2 is positive 1.5, plus 4 is 5.5. And then when we do 3, we get -4 times -1/2, which is 2, plus 4, that takes us up to 6. And then for the last one, which is 5, we have -1, and then plus 4, which is 3. So we have 5 and then 3. So this graph got reflected and compressed, and the only thing we need to make sure we do is when we get to here, we do the arrow over. That was a little messy, but we want to make sure it follows the pattern of the graph. So you can see it's reflected, smushed, and shifted. Okay, this problem also asks us to do a couple of things other than graph it. It says to find the domain. So the domain is, are there any boundaries left to right? So if you look right here, when we're coming off of our original, it wants us to do the domain and range for our transform. So I'm looking at the pink graph. It's from -infinity, but this is the boundary line right there for the x's. So the biggest x value it can be is 5. So I'll do x such that x is less than or equal to 5. And then for the range, you're going to think low to high. So the lowest value it can be is like right here, which looks like it's at 3, and the highest value is up there, which is 6.5. And just because it's the range, we're going to switch to y, and it's going to be 3 is less than or equal to y, which is less than or equal to 6.5. And then it asks you to do increasing and decreasing as well. So let's look at those. Those are a little different. You always use no equal to sign on these. So here, as I coast along here, it's constant. So it's not going up or down a hill. Then when I go here, it's going down. So what's the interval right there that it's going down? So I'm going to put decreasing on here. X such that, and that is from -2 to -1. Okay, and it's X. It's always how long is it decreasing for? Then we're going to go back and we're going to see that it starts going uphill right there. So the uphill is going to happen X such that that is going uphill from -1 to 0. I'm just going to kind of like highlight these so that you guys can also see where I'm getting those values. So what I'm doing really is connecting these down to the x-axis. How long is the x-axis? Okay, next one is it's going downhill from 0 to 2. So right there, so since that's decreasing, I'm just going to add that in right there. And that's still that one. Then I'm going to go back uphill, and that's going to be from 2 to 3. That I'm going back up that hill. And we just use the word or in between those. It's going uphill here or here. But that graph isn't finished. It is still going downhill right there. So there's 3 highlights of it going downhill, and it's going downhill from 3 to 5. So we've got 3 of them for decreasing. And there we go. All right, number 5 shows this graph, and they want us to write the equation. So they don't give us the specifics, like they don't say cubic function or quadratic function, so we can just use g of x and f of x. And so what we're going to do is like pick this point and see how it moved. And that point went left 3, and then it went down 1. But we can also see that the graph has also changed. So if you pick one point to the right on there, the height is 1. If you pick here one point to the right, the height is 2. So that's going to tell us that A is 2. So we're going to write g of x equals 2 times f of, again, because we don't have the actual equation, left 3, the opposite would be plus 3, and then we have down 1, so that would be minus 1. Okay, this one is asking us to identify the parent graphs and then state the transformation. So this one is different now because you'll notice that they're actually giving us an equation. So our parent graph is going to be y equals x cubed, or f of x equals x cubed. And so then we would make a table for that. And then you're just going to plug these 5 x values in, or some of you have them memorized because we've done it a bunch this chapter. And then we're just going to do the transformations. So state the transformations is what actually it says. So vert, stretch, make sure you put vert and by 5. Don't just write vert stretch, be specific on your exam. So that's going to be multiplying all of these by 5. And then we have a -4 in with the x, so it's going to be the opposite, because whenever it's in with the x, it's always opposite. So it's going to be right 4, so that means we would add 4 to all of these. And then we would simplify our tables and get a new graph. So right now, our graph looks like this right here. So this is our parent graph. If it doesn't say on the test that you have to graph the parent graph, then you don't have to. But if it's helpful for you, then please do. And then we're going to do this. -2 plus 4 is 2, and it's 2 negative 40. So that's really far down. I'll just put a little point down there at the bottom just to remind me of the shape. -1 plus 4 is 3, and then -5. So 3, -5. Then I have 4, 0. And then I have 5, 5. When I do the math for that, wait. I feel like I have something wrong. Hold on, I did some funky math back here. I don't know why I put this one. This one is 3, -5. Let me just fix that. And then there's one at 640. So it's gonna come down kind of like that. And I'm gonna do this last one real quick just because I want to finish this page. So xy, same, -2, -1, 0, 1, 2, -8, 0, sorry, -8, -1, 0, 1, 8. And then we're going to multiply all those by -1/2 because there is a vert comp by -1/2. And then I'm going to go up 3 because that 3 is not in with the x. And then I'm going to plot those points. So to simplify this table, we didn't do anything to the x's, so we're just going to copy those down. And then we're going to simplify. Make sure you put those over 1 when you're multiplying fractions. So that's going to be +4 plus 3, which is 7. -2, 7. Then we're going to have +0.5 plus 3, so that's 3.5. And if ever your numbers are off and you see that in the graph, just go back and do your math. This is going to be 3, -1/2, and then so that's going to be 2.5 when I do that math. And then half of 8, and then it's -4 plus 3 is -1. So you can see we still have the integrity of that shape right there. All right, on to the back side. This one actually says that it is a cubic function. So we are going to make sure that when we write it as a cubic function and not just a general function. So the way we do this is we find our HK. So that is -2, 1. And then we also go 1 point to the right. So that's going to be right here. And we can see that we went down 1, 2, 3, 4 squares down. So that means that A is going to be -4. So when we go to write our equation, we're going to go g of x equals -4 times x plus 2 cubed plus 1. And then again, the h and the k are coming into play here. Whatever's in with the x is always opposite, and then the k is the same because it's a y coordinate. All right, now we're moving on to the 1.4 section of our unit, and this one is going to be on graphing polynomials. So the first thing that we're going to do is we are going to multiply the first terms of all of these, and that would give us 1x cubed. So the max number of terms is always the power -1, so it's going to have 2. Now because there's an x here, my zeros are going to be 0, 0. negative 2, 0, and negative 1, 0. And then because we're graphing these, I need to do plus minus, and then I need to do even odd. So because this leading coefficient is positive, the graph is going to rise to the right. So this is right. And then right here, because the exponent is odd, it's going to be the opposite of that. So you always have to do the right first, so that's going to be fall. So then what I'm going to do is plot my zeros. I don't have any multiplicities other than 1, so these all have odd multiplicities, which means each of them is going to cross through the graph. So the right is going to rise. Oops. The right is going to rise, and then the left is going to fall, and then these cross through. All of these cross through, so then you can just connect the graph because this one has to cross through too. So it looks like that-ish. Close enough. Next one, do the same thing, figure out what your first term is, but be careful because this right here, x minus 2, has a multiplicity of 2, so when we go to find that first term, we have to take that into consideration. So that's going to be negative 1, and then it's going to be x to the 4th power. And then there's going to be a bunch of other stuff if we multiplied it out, but to graph we don't need that. So the number of turns I'm going to be having is 4 minus 1. That's the max number of turns. And then my zeros are going to be 0, 0 from this guy. Remember, the negative isn't affecting the x-intercepts. It would only affect the y, which we don't ask you about. And then this one's going to cross because it's only an exponent of 1, which is an odd number. This one's going to bump because it's an even number. And then this one's going to cross because that exponent is odd. So we're going to plot those 0, 0, 2, 0, negative 1, 0. Then we're going to do our end behavior. So that's plus minus. So this is negative. So it's going to fall to the right. So I'm going to make it fall. And then it's even odd, which this is an even exponent. So it's going to have the same end behavior. So it's also going to fall. Even has same, odd has opposite. Then I'm going to look at these at negative 1, it's crossing through, and at 2, it's bumping. So that means instead of crossing through, it's going to turn around, and at 0, it's crossing through. So then you can kind of just connect the dots from there. Okay. Let's go over here to this question, and it asks us to consider this and just label true or false for each of these. So it says it is tangent to the x-axis at x equals 0. So first of all, tangent is going to mean that it bumps. So bump and tangent are synonymous. So I'm just going to make sure that I have the first term here, which would be negative 1. And then that's a bump at 0, 0. This one is not going to bump, it's going to cross. And this one is not going to bump, it's going to cross. And again, the reason for that is that these have odd exponents. Anyways, the first term is going to be negative 1 x to the 4th. And we know if we multiply that out, there's going to be a bunch of other stuff, but this is really all we need. So it says it's going to be tangent to the x-axis, which is, you know, the x-axis at x equals 0. So what it's really saying is it going to bump at 0? And we can see right here, because this has an exponent that's an even number, that is going to be true. The next one says that it crosses the x-axis at x equals 4. But if you look right here, this one, it says negative 4. So that one's not going to be correct, so it will be false. This one says it falls to the right and rises on the left. So let's do this plus minus. It's negative, so it is going to fall to the right. So that's correct. And then we have to do even odd to see what it's doing to the left. And so because this is even, it's going to have the same end behavior. So that's going to also fall, but this says rises. So because both pieces aren't true, the whole statement is going to be marked false. And then this says it has 3 turns. Turns should be, it should say a maximum of 3 turns, but we'll take it 4 minus 1 is 3, so that would be true. Then we get into the part where we got to write these. So to write them, what you're going to want to do is identify your zeros, and as you're identifying them, make sure that you put whether or not they bump or cross, because that's going to make a difference. So this is 2, 0, and then that one is 3, 0, and then we are rising here. So that's going to tell us our leading coefficient is positive. So g of x, you could pick whatever letter, equals, it's going to be a positive 1, and then I have x plus 1, because I'm going to do the opposite of that negative 1, but I'm going to make that squared because it's bumping or is tangent to the x-axis. Then I have x minus 2, and then I have x minus 3. Moving on to the next one. Ooh, this one looks fun. Okay, same thing. Identify your x-intercepts. So that's negative 2, 0, and that's definitely a bump. Then we have 0, 0, which is also definitely a bump. And then we have 1, 0, which is crossing through. Then we're going to see that to the right, the behavior of the graph is to fall. So we know that our leading coefficient is negative. So if I make this one h of x, I'm going to start with a negative because of falling to the right. And then my first 0 is going to be written as a factor, and it's the opposite. So I'm going to put x plus 2 squared. And then this one could be x minus 0 squared. I'll clean that up in a second because of this guy. And then the last one is just x minus 1 because it's crossing through, so I don't want to change the exponent on that. So altogether, the way this one would look in proper form, we'd put the x squared in the front, so the x minus 0 goes in the front, and then it would look like that. Okay, for our last two, we're going to expand using Pascal's triangle. So what we're going to do is we're going to set up our chart. And make sure you leave yourself enough room here. So this is going to be the triangle. And then we have A, and then we have 3. And then we're going to do our triangle. So because this is 4, when I do the pattern for Pascal's triangle, which is adding the numbers, so 3 plus 3 is 6, 3 plus 1 is 4, and always first and last number are 1. I'm stopping at this row because the second number is 4. So I'm going to put that here, 1, 4, 6, 4, 1. And then we can continue. It's the powers of the first one are going to go up, matching that power right there. So a to the 4th, a to the 3rd, a squared, a to the 1st, and a to the 0. And if I clean those up, because it's pretty easy to do, and put them in proper form, I get that. And then for the other ones down here, we start with 0. Or if you want, you can start up here and then work backwards and go down. Either way, your choice. And then we're going to clean those up. So I'm going to cross those off because I already simplified them. This is 1, 3, 9, 27, and 81. And then from here, you're just going to multiply the entire column. So I have 1 times a to the 4th times 1, which is a to the 4th. And then I have 4 times 3, which is 12 times a cubed. So plus 12a cubed. Then I have 6 times 9, which is 54. And then a squared. And 27 times 4 is 108 times A. And then 81 times 1 times 1 is 81. So that's that one. And then for our very last problem, we're going to do the same exact thing. We're going to set up our triangle and our variables in this chart. So there's the numbers that are going to come from the triangle. I'm just going to use the triangle up above, but now I'm just going to add till I get to the second number is 5, because that's the power there. So I have 1, 5, 10, 10, 5, and 1. And then we're just gonna do the same thing we did the last time. The first term here is 3h. Always put it in parentheses. So this is gonna be 3h to the 5th, 3h to the 4th, 3h to the 3rd, 3h to the 2nd, 3h to the 1st, and 3h to the 0. So I'm going to clean those up. This is 243h to the 5th. This is 81h to the 4th. This is 27h cubed. This is 9h squared. That's 3h, and that just goes back to 1. And then for this one, we have -2. So -2 to the 0. So notice how it starts the opposite power. You're going to start with 0 and go up to the power of whatever that is when you do the second term in the binomial. Okay, so then here this is 1, this is -2, that's +4, that's -8. That's +16, and that's -32. And then from here, we're just going to multiply each column, so you have to be really careful. We have 1, 243, 1, so that's 243h to the 5th. And then we have -2 times 5 times 81. So I'm going to do -2 times 5, which is -10 times 81 is -810h to the 4th. And then I have 10 and 27 and 4. 4 times 27 is 108. So that's going to be 1080 when I multiply it by the 10, and then h cubed. And then this one I have -8 times 9 is -72, and then times 10, so -720h squared. And then this one, 5 times 3 times 16, but I'm just going to do this, 5 times 3 times 16. And that gives me 240. So that's going to be positive 240h, and then minus 32, because 1 times 1 times -32, and that's it.